Hey guys, this is Mr. Sal. Don't forget to like, comment, and subscribe below. This is a lesson for 8th grade on two-way tables and analyzing them as well. There are two different types of random variables when looking at bivariate data, so it's got two variables. Quantitative random variables and categorical random variables. So far in this chapter we have studied quantitative random variables. Quantitative just means that there's some kind of value associated with it, specifically in numbers. Quantitative random variables can be counted or measured. For example, we can count the number of assists and rebounds that a player on a Zoomies team had during the game. We can count the amount that Jenny made in tips each day. We can measure a person's shoe size and their height. We can measure the amount of time it takes to say a tongue twister. A categorical random variable represents a quality or a name. Suppose we were interested in determining if there is an association between a person's gender and whether or not that person has pierced ears, which we will look at later. We would interview people and classify them as male or female, and a yes, ears pierced, or no, ears not pierced. Suppose we were interested in whether a person's favorite color is associated with their favorite holiday. We would categorize a person according to their favorite color, red, orange, yellow, and their favorite holiday, Christmas, Thanksgiving, Halloween, Hanukkah, etc. All right. Determine if the following random variables represent data that is quantitative or categorical. Number 1, gender of babies born in the Riverton Hospital for the month of June. Well, for this, we're looking at the gender of babies, which is categorical. We're not really looking at the value or how many of the babies, just the genders, right? Count. Number 2, thickness of the plastic for various types of water bottles. Well, we're looking at thickness here, which is a measurement, so that would be quantitative. Favorite ice cream flavor chosen from the following options: chocolate, vanilla, or strawberry. Now this one, again, we're not really looking at the numbers right account. We're looking at categories of ice cream flavors, such as those three. So it is categorical. And then finally, the number of pages you can read of your favorite book before you fall asleep. That one is the number of pages, so it is quantitative. In the previous sections, we summarized and displayed quantitative data using a scatter plot. In this section, we will summarize and display categorical bivariate data using a two-way frequency table. A two-way frequency table is two-way because each bivariate data entry is composed of an ordered pair from two categorical random variables. Well, as it turns out, that's our objective for this entire unit, is just that you guys can be able to do and make two-way frequency tables. Use the given information to complete the two-way frequency table about the eating habits of 595 students at Copperidge Middle School. 190 male students eat breakfast regularly out of 320 total males surveyed. All right, so a two-way table, notice over here, we have these categorized by, first we got the gender up in here, with male and female. And then down here on the left, we have, do they eat breakfast? So breakfast, yes or no? There we go, be fast because breakfast is such a long word. And then we categorize them by eating breakfast, don't eat breakfast, male and female for the genders, two ways, two categories, two-way table. Bam. Then at the bottom down here, we have the total. This is the total row. So this would be the total, this box right here would represent the total number of males. Total males. This box would represent total females. And then this box would represent the total totals. Okay? And then, for example, this box right here. Okay, what do you guys think this one would represent?
That is
165.
yeah, breakfast regularly.
Not the number, what does it represent?
Do not eat breakfast regularly.
Yeah, it's females that do not eat breakfast regular.
That's me.
Alright, so let's go into those values I was looking at. At the top up in count, it says that there was 595 students at this school. So we got to figure out where to put this 595. Well, that's the total number of students, not just males and females, but also students that eat breakfast regularly and don't. So we should get a total of 595 down here, no matter what. Alright, so that's where our 595 goes. Next up, they tell us that 190 male students eat breakfast regular. So we're looking at males now. Males that eat breakfast regular, bam, 190, right? But then they finish that sentence off right here. 320 total males. So we're looking for total males right here
So then you do
at 320. Well, let's look at what other information they had given us. So I got this 295 right here. So it's students that do not eat breakfast regularly. It didn't mention anything about the gender. So it's just the total number of students that do not eat breakfast regular. So that would be right here, 295. And then it's a 165 females do not eat breakfast regular. So we look at do not eat breakfast regular females, bam, 165, round it down. Now that we have this, all these values, not that we even needed all of them, but we should be able to fill in the rest of this table, kind of like a Sudoku puzzle, but we're just looking at addition and subtraction now.
I got one.
So, for example, which one do you got? Yeah, so this box would be 320 minus 190.
Equals 130.
And yes, there'd be 130 in this box. That means that there was 130 males that do not eat breakfast regular. Well, next up, we could find the total number of females. Because right here, they told us how many total students there were and how many males. So to find the total number of females, we'll take the students, 595, and subtract 320 right here. So we get 275 total females, which then should allow us to figure out how many females do eat breakfast regular. So yeah, we would do 275 minus 165.
Which then?
So yeah, we got 110, and then we just got one final total to get right here, and that would be the total number of students, male and females, that do eat breakfast regular.
you just add both.
All right, so yeah, that's a good question. You could add 190 and 110. Or you could take 595 and subtract 295. It should give you the same answer both ways. Okay. So as it turns out, the two-way table should give you two ways to find the answers for these, some of the times at least. I'm going to add because I like addition a little bit better. 190 plus 110. So these black values are values that we had to find on our own, and then the colored ones right here. Those ones represent values that were given to us originally. And this is a two-way table. Now later on we'll look at the relative frequencies for these. You want to remember that word because we're going to talk about them. That's just percentages, but they have to be based on, because we're looking at totals for, in this case, we got totals for rows, right here, and totals for columns. But there's one last thing we should check on at these before we move on. So what I should do is I should take the total in this columns, 320 plus 275. And if I add 320 plus 275, what do I get?
You get 500.
595. Now that's what we should have gotten, right? But then just to double check, we'll take 300 and also add 295, and what do we get?
595.
Still 595. So it checks off both ways to show that our totals add up at least for these. Now we could check all of them. 130 plus 165 is 295. 110 plus 165 is 275, and 190 plus 130 is 320. That's a lot of checking, but it is a good way on the test to know that your answers are correct. Well, let's answer these other questions then. How many females total were surveyed? That's this one right here. That is 275 total
275.
females, right? Because we're looking at the females column right here. And that's the total number of females, 275. How many people surveyed eat breakfast regular? So we're looking at peoples, it's both, it's combined. So we have, yeah, very good, 300 total peoples eat breakfast regular. How many people total were surveyed though? Very good, that was the total of all the totals, 595. And then how many males surveyed do not eat breakfast regular?
130.
Yeah, we got 130 on that one, very good. All right, there are more questions for us up in count. So how many females surveyed eat breakfast regular? 110, very good. What percentage of the total number of people surveyed? So let's set this up before we figure this one out. What percentage? So we're dividing this as the total number of people surveyed, which was 595. And how many of them eat breakfast regular? I got 300 on that, right? So in our calculator, we're just going to put this in. You can multiply it by 100 to get the percent, which is what it wants, the percentage. So I got 50.4%. Next up, what percentage of the females surveyed? So the female surveyed, there were 275 females. And how many of them eat breakfast regular? It says 110. So we'll multiply that by 100 to get the percentage as well. 40% of the female surveyed can eat breakfast regularly. So what percentage of the people who eat breakfast regularly? Let's go and write that in. People who eat breakfast regularly, there were 300. And how many of those are male? 190 of them are. So these percentages that we're finding are the relative frequencies. We'll multiply it by 100 to get the percent. 63.3%, it was repeating, but we're just going to round it, which is okay. And next up, what percentage of the total number of people surveyed? So the total number of people surveyed, 595. How many of them are females who do not eat breakfast regular? So that appears to be 165 right here. So I'll multiply that by 100 to get the percent. So 27.7% of the total number of people surveyed are females who do not eat breakfast regular. Tamara wondered if there is an association between age and favorite flavor of ice cream, chocolate, strawberry, and vanilla. She surveyed 200 children in different age ranges. The table below shows the results of her survey. Tamara gives us the following information. 1/2 of the children surveyed choose chocolate as their favorite flavor. 25% of the children surveyed were in the age range of 8 to 12 years old. 2/5 of the children surveyed were in the age range of 13 to 17 years old. 50% of the children in the age range of 3 to 7 years old chose chocolate as their favorite flavor. And then 50 children chose strawberry as their favorite flavor. All right, that's plenty of information to complete the table up in here. And they already told us up here that she surveyed 200 children, which they also put down there in the table, 200 total children's. So let's go through these and figure out what we can fill in up here. So to start off, it says half of the children surveyed chose chocolate as their favorite flavor. So we're going to take, that's the total number of children who like chocolates. And there were 200 total. We're going to cut that in half. Bam, 100 children's choose chocolates as their favorite flavor. Next up, 25% of the children surveyed in the age range 8 to 12 are in the age range of 8 to 12. So that would be 8 to 12 total number of children's. 25% of these. So we got, well, you could use a percent proportion. 25% out of 100 is the same as some number out of 200. And that would be 50. The percent proportion gives you the percent over 100 always equals the part divided by the whole. The whole is all the children's. The part is the children's in the age range 8 to 12. Then I would use fish method to solve it, but some people like bow tie method, means and extremes, scale factors, cross multiplication, all those fun ones. All right, next up, we got 2/5 of the children surveyed were in the age range 13 to 17. That's going to be this box. Total number of children in that age range. And it's 2/5. So I'm going to take 2/5, which is the same as some number out of 200s. So again, fish method, whatever. I'm going to use just the scale factors. Is 5 times 40 is 200. So 2 times 40 is 80. 80 children surveyed in the age ranges 13 to 17. Next up, we got 50% of the children in the age range 3 to 7. So we're looking right here in this row. 50% of the children in that age range chose chocolate as their favorite flavor. So that's going to be this box. But before we do that one, we're going to have to figure out this one right here. So we got to take the 200, take out 80, then take out 50, and that will tell us how many. That's going to be 70. Right here. So 70 of the children surveyed were in the age range of 3 to 7, which now allows us to figure out how many likes the chocolates. And it was 50% of them. So I got a percent proportion, 50 out of 100, equals some number of children out of 70. I can use fish method on this one, so 70 times 50 divided by 100 is x, and that would be 35 children chose chocolate in the age range 3 to 7. And then finally, just with the clues that were given, I'm not even sure if we would need this one. Maybe we do. In any case, we have 50 children choose strawberry as their favorite flavor. So that's 50 of the children all together. That's this box, 50. 50 children's. And now we can go in and just fill in all the boxes with the corresponding values. But they need to add up to each other, right? So like this one right here, we got 200 minus 100 minus the 50, which is 50. So 50 of the children chose vanilla as their flavor ice cream of choice. And then this one right here, I'm looking at chocolate for 13 to 17s. 100 minus 25 minus 35, 60, so 40. Bam. And strawberry for ages 3 to 7. We can do that one. 50 minus 12 minus 12, 26. And then we got the rest of these. Vanilla for 13 to 17-year-olds, 80 minus 40 minus 12 is 28. 8 to 12-year-olds, 50 minus 12 minus 25, 13. And then ages 3 to 7 for vanilla, 70 minus 35 minus 26, 9er. Keen collects data about the number of people who own a smartphone and if they also own an MP3 player. He gives you the following information. 25 people surveyed owned smartphones. 20 people that own a smartphone do not own an MP3 player. 9 people do not own smartphones, but they do own an MP3 player. 24 people do not own an MP3 player. So take a moment and design and complete a two-way frequency table to show the display the data. Alright, so I'm not going to finish this yet, but I'm just going to show you guys. We don't need this box ever, really, for two-way tables. And some of you guys have figured out that this is a total column, because you always have a total column. And you also always have a total row.
You're joking.
All right, now some of you guys are wondering what to do with the two categories. It doesn't need to go in any of the boxes, but I'm going to put my MP3s up in here. And then we also had, what was the other one? CD players? That was it? No, smartphones.
Smartphone.
All right, so here's our smartphone stuff. So hopefully this helps you guys get started to finish this up in here. All right, some of you guys are continuing forwards. We can look at what he said, or is it she? Yeah, he. Keen said that 25 people surveyed own smartphones. And then the second one talks about MP3 players, but it says do not own. So for MP3 players, you either has one
Or the down.
or you has not one. And it should work the same way with the smartphones. You either has one or has not. So now that we've got the columns and the rows labeled, we should be able to fill in all the blanks up and count. For example, 25 people surveyed owned smartphones. So that's has a smartphone, total 25 of them. Then we got 20 people that own a smartphone, do not own an MP3. So it has a smartphone, but it has not an MP3. And that was 20 right here. The next bullet point, 9 people do not own smartphones, but they do own an MP3. So has not smartphone, but has MP3, niner. And then finally, the last bullet point, 24 people do not own an MP3. So that's MP3 has not, 24. So now that we've gone this far, take a moment and fill out the rest. So how many people own a smartphone and an MP3 player? 5. And then how many people own an MP3 player? 14. Now that we are comfortable making a two-way frequency table, we are going to see what conclusions we can draw from them. 7. The table below displays the data Julie gathered on gender and the type of movie a person prefers. Use numerical evidence from the table to answer the questions below. A. Julie is showing a movie at a party at which males and females will be present. Which type or types of movies should Julie show? Alright, so we may want to look at preferences for all of the genders up in here. Genders and then types of movies. And this is relative frequency that we're talking about. We're going to start doing it by row. So for example, romance, there were 15 males who said romance out of 220 of them, which as a percent, so we got 7% of the males prefer romances. Then we'll do comedy for the males, 77 out of 220, which I believe is 35%. Then we got action, 100 males out of 220. All right, so that gives us, those percentages are relative frequency for males. Oh, I got to do that. I wrote that in the wrong place. All right, there we go. All right, next up are the females. So females that prefer romance, we got 80 out of 280. All right, let's go ahead and figure out the others as well. All right, so that gives us the relative frequencies by rows for male and female preference of movies. So going back to the original question now, Julie is showing a movie at a party at which males and females will be present. Which one should she choose?
Comedy.
Yeah, it looks like comedy is going to be her best choice because it's the most even between the two, and it has higher numbers for both of them. So, notice the numbers are different there, 77 and 98, but we got the same percentages because we were comparing those to their totals for male and female, which brings their percentages equal. So B, Julie is showing a movie at a party at which only males will be present. Which type or types of movies should she show? Which type of movie should she show with just males?
Action.
Yeah, action. And then just as a backup, looks like comedy would be the backup for the males. Okay. All right, see, Julie is showing a movie at which only females will be present. Which type of movies should she show? Well, there's a lot more females that chose comedy. And then romance would be the backup with the female party. So let's determine whether the following statement is true or false based on the data in the table. Put a T on the line if it's true, F if it's false. Use numerical evidence to support your answer. Males and females have an equal likelihood of choosing comedy movies. The answer right now is yes, because both of them have a 35% chance, or the survey shows that 35% of both chose comedy. In the previous section, you made a frequency table about gender and eating breakfast. Well, we did actually, but is there an association between gender and whether or not a person eats breakfast regular? Yes, there is an association. There are more males that eat breakfast regularly than females. And we can see there's a higher number of females that do not eat breakfast regularly than males. So it appears that by gender, if this table were correct, we could assume that males eat breakfast more often regularly than women. Eddie wanted to determine whether there is an association between gender and whether or not a person has pierced ears. He collected data from a random sample of young adults aged 13 to 18. Looking at this data, now we don't know where it came from, it's just made up. Is there an association between gender and whether or not a person has their ears pierced?
No.
Clearly, the answer is
No.
yes.
That's so weird. Why?
All Y's are weird.
Okay.
Yes, there is. We can see there's a lot more females with ears pierced and a lot more males with ears not pierced. So at least at this age group, we could say yes, there is an association between gender and ears piercedness.